Good day, everybody. How are you all doing? Today, we will work on a problem on a sampling distribution, and I will read the problem just for you. Certain tubes manufactured by a company has a mean lifetime of 800 hours with a standard deviation of 60 hours. Find the probability that a random sample of 16 tubes taken from the group will have a mean lifetime between 790 and 810 hours. Part B, less than 785 hours, and part C, more than 820 hours. Like I was saying, this is a sampling distribution of the means. So, if I draw the bell-shaped diagram, okay, on the horizontal axis I have sample mean. The center where the relative frequency is highest, so this is the sampling distribution of sample means or probability distribution of x bar. Okay, from central limit theorem, the center of the sampling distribution is x bar is mu x bar, and that is equal to mean of the population okay. So mu x bar is equal to, in this case, if we go up and read, the mean is 800 hours. Also from central limit theorem, CLT is central limit theorem, the standard deviation of the sampling distribution is equal to standard deviation of the population divided by square root of n. Now we are given the standard deviation of the population is 60 hours, and remember we are picking up a sample of size 16, okay, from 16 tubes, so my n is 16. So standard deviation of the population is 60, that is divided by sample size square root of 16, and sigma x bar, which is also called standard error of the mean, sigma x bar is equal to 60 divided by square root of 16, or 60 divided by 4, since square root of 16 is 4, is 15. Okay. Now part A. For part A, we have to find the probability the random sample of 16 tubes taken from the group will have a mean lifetime between 790 and 810. Okay, 790 and 810. So we have to, for part A, we have to find 790, probability of 790 less than x bar less than 810. Okay, and we will use TI-84 in that case. So we will press the second button in the TI-84 calculator key on the top left. Then we will press the verse key in the second row of keys, and then scroll down to, with the down arrow key, to normal CDF. Okay, so my lower will be 790, my upper is equal to 810, my mean is the mean of the population, which is 800, My sigma is the sigma x bar, and that is equal to only 15. And then I will bring the cursor down on pest and hit enter twice. Hence, probability that x bar is between 790 and 810 is equal to. So I use the calculator, I do exactly what I wrote. I press the second button, then the verse key, which is in the third row. Then I scroll down to normal CDF. My lower is 790. My upper is 810. My mean is 800. And my standard deviation is 15. And I go down on pest and hit enter twice. Okay, I forgot to write down here. It is enter twice after pest. Enter twice. Okay, and the answer is 0.495. So that is the answer for part A. Okay, let's do so. Just to summarize, what I did is I found out the mean of the sampling distribution is equal to mean of the population, and the standard deviation of the sampling distribution, which is also called standard error of the mean, is standard deviation of the population divided by square root of n. Okay, so in this case 60 divided by square root of 16, or 60 divided by 4, sigma x bar equal to 15. With that information, I found out what is the probability that x bar is between 790 and 810. My lower is 790, my upper is 810, my mean is 800, and my standard deviation is 15. Please do not quit. I will give you some important tip at the end of this program. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. So we will continue with part B. Part B says less than 785 hours. So part B, probability x bar less than 785 hours. Okay, so if I draw the picture over here, so at my center, mu x bar is equal to 800. My sigma x bar, I have determined before, is 15, and I want the probability that x bar is less than 785. Notice that 785 is less than 800, so it will lie on the left of the center. Further, we want the area below 785. So we want to find out px bar less than 785. Again, use second key, verse key, and then scroll down to normal CDF number 2, which is normal CDF. Now in this case, the lower, we start from the extreme left. Remember, the curve extends to negative infinity on the left. So this is minus 1 E99. E stands for exponent. This is minus 1 followed by 99 zeros. Okay, so we press the minus sign next to the enter on the left, and then type 1. To get E in the calculator, we have to press the second button, okay, and then the comma button on top of 7. That will give us the small cap E, and then we will type 99. Okay, so let's try it. Second, verse 2, my lower is minus next to the enter. Again, remember, this minus is next to enter on TI-84. And we press the second button, or we can type a 1, then the second button and the comma button on top of 7 will give me the small cap E, and then 99. Okay, so minus 1, second button, and then the comma button gives the E, and then 99. What is my upper? My upper is 785. Upper is 785. My mean and standard deviation do not change from part A. So mean is still 800 and sigma is still 15. Okay. And then I go down to best and of course enter twice. This is key. Enter twice. Okay. So hence P x bar less than 785 is equal to 0.1587, or there is a 15.87% chance that the sample mean will be less than 785. The key point to remember here, our calculation in TI-84 starts from left boundary, which is a very large negative number, so minus, then 1, then E, which is second, then comma. E stands for exponent 99, that means minus 1 followed by 99 zeros is my lower boundary. Now we will do the last part, which is more than 820 hours. More than 820 hours. So again, see more than 820 hours. Same picture. So the center is mu x bar equal to 800, sigma x bar equal to 15. So as you realize 1520. Okay, as you realize the number x bar, we want to find out p x bar more than 820. So 820 is greater than 800, so it will lie on the right of 800 on the horizontal axis. So this is your 820, and we want the area to the right of 820. So again, we will second verse to normal CDF. Now remember, the calculation in the calculator starts from the lower boundary. So in this case, the lower is 820, which is the start of the calculation. Upper is a very large number on the right. It's infinity. So again, we type 1, then second button, then comma button. This is important. Where is the comma button? On top of the 7. This is the comma button. That will give you the capital E, and then we of course do 99. Okay, so E99. Okay, and the mean and the standard deviation still remain the same. Mean is 800, sigma is 15. So probability that the sample mean is greater than 820 is equal to, so second verse 2. So we start our calculation from 820. Our upper boundary is a very large number on the right, which is 1E99 on the right. Okay, so 1, then second button, comma button on top of the 7 button, and then 99. Mean and standard deviation do not change. Go down to PEST and hit enter and enter. And the answer is 0.0912. So there is a 9% chance that the sample mean will be greater than 820. So I just highlight the answer for part B and part C. So this is the end of my presentation, but I wanted to give you some important tip. The first tip is to remember that this is a sampling distribution problem. What is a sampling distribution? Is probability distribution of x bar. Probability distribution of x bar. That means we have x bar on the horizontal axis and probability or relative frequency on the vertical axis. Now, so we are dealing with the probability distribution of x bar. Hence, we will have to use central limit theorem, which states that the center or mean of the sampling distribution, mu x bar, is equal to mu, which is the mean of the population, which in this case is 800. So mu x bar is 800. The other thing that people often forget, because we are dealing with sampling distribution, the standard deviation of the sampling distribution, or which is also called uh, standard deviation of the sampling distribution, or standard error of the mean, is equal to standard deviation of the population divided by square root of n. Sometimes people forget to divide by square root of n. In this case, population standard deviation is 60 divided by square root of 16, which is 60 divided by 4 is 15. Notice the sampling distribution standard deviation is thinner than the population standard deviation. This is a key point in sampling distribution, that the standard error of the mean, or the standard deviation of the sampling distribution, is the standard deviation of the population divided by square root of n. I will stop here today. If you have any question or comment, please do not hesitate to write me a note, and please give me a thumbs up if you really like this video. I really appreciate that. That motivates me to produce more interesting videos. Okay, and if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button, and please let YouTube know that you'd like to be notified every time I upload a new video. So just hit the bell, and please do not forget to watch me tomorrow, when I'll be back with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice